Hi, my name is Nick DeFilippo, and I want to talk about the new YouTube series that I'm coming out with. And this new YouTube series is going to deal with getting started with Arduinos. And I know there are a lot of Arduino tutorials out there already. Jeremy Blum actually has a great tutorial series that I'll link to in the description. But with my tutorial series, I really want to try to target someone who's never programmed before or has very little programming experience. So I want to sort of explain everything I do in a lot of detail. And I know that I still have to work out some of the problems. I have to show you what's on my screen and show you what's actually physically going on with the Arduino and the circuits that we build. So I'm still trying to work that out, but hopefully this will be a great series. Okay, so the first thing I want to go over is different features that's on the Arduino board, and I want to start with how to power the board. With the Arduino Uno, we have two different options. We have a USB connector, which is what a lot of beginners will use and what I'm going to use for this tutorial, because we also need to connect to the computer to upload the sketches that we program. The other way to power the board is with this wall adapter that would plug in right here. Now, if you choose to use this wall adapter plug-in, you're going to have to make sure the actual wall power supply gives between 7 and 12 volts. And that information can be found on a power supply right here. Now, I'm not sure if you can read this, so I Googled an image of a power adapter, and this is what all the power adapters say. It shows you that the input is 100 to 240 volts at 50 to 60 hertz. This is just the actual what we plug in through the wall. And the output of this particular supply is going to be 12 volts. So this right here is 12 volts. This is DC instead of the AC that our wall has, and it's giving us 5 amps. And then finally, this right here tells us that our center pin, so this black part is our center pin, is positive, and our the wall is negative. So if you look at the power adapter, there's a pin on the inside here. That's going to be our positive voltage, and then this metal around the outside is going to be our ground. So it's important that all those specifications are met. Alright, so the next thing I want to talk about are the header pins, and these header pins are right here and over here, and they're broken up based on their functionality. So on this side we have power and analog in. On this side we have our digital pins. Now digital means that you can either have high or low. So these can either give 0 volts or 5 volts out. Pins 0 and 1 are reserved for the TX and RX, so transmit and receive. So when this Arduino talks to the computer. So typically we don't want to plug into pin 0 or 1. Pins 2 through 13 are then our digital inputs and outputs. Now this little squiggly line means PWM, which is pulse width modulation. So the pins 3, 5, 6, 9, 10, and 11 support pulse width modulation. And that's a feature we'll talk about in a later video. It's a more advanced feature. So all these pins can be configured as input, where they're going to read in state, or output, where they're going to output a state of high or low. And high is 5 volts and low is 0 volts. On the other side, we have our analog input, so A0 through A5, and this is how we read in voltages that are in between 0 and 5 volts. So sometimes sensors that we want to interface to don't just give us 0 volts or 5 volts, they're going to maybe give us 2.3 volts. And we're going to read that voltage into the analog input, and we're going to get a number. We'll cover that again in a later video. Now, what's important to note with the analog input is that we don't want to feed any voltage that's higher than 5 volts into the analog input. And then finally we have this power rail right here, and you notice you can pull ground. So if you have to ground your devices, you connect it to ground. You can get 5 volts from this and 3.3 volts from this. Now, it's not always the greatest idea to power devices with the Arduino because of the power consumption that some of these devices will have, and your Arduino might not be able to power it, and you could hurt your Arduino. However, a lot of the things, the LEDs that we'll be doing for the first few tutorials, you'll be fine. Alright, so now that you have your Arduino, plug it into the computer, the first thing you want to do is go to www.arduino.cc. And when you're at this website, you're going to want to go to download, and depending on what operating system you're using, you want a Windows installer if you're using Windows, which is what I'm using. So you'll click it. Arduino is open source, so it's free. So you can just download, or you can donate some amount. So if you click just download, your download will start. Once you install the Arduino software that you're downloading, you can double click on the program that installs, and I'm just going to open a new sketch, and this is what you'll see. I think I'm in screen right here. So you'll see these 2 functions that we have, and right here we have a void setup function, and here we have a void loop function. When we deal with Arduino, 2 things are going to happen. When the Arduino first starts, it's going to run this void setup function 1 time. So whatever code we put in here, it's going to run once. Then what's going to happen is it's going to go to this void loop function, and it's going to constantly repeat, and it's going to constantly loop while it's plugged in. So these are the 2 functions that every Arduino script needs. So let's just come up with a way to blink an LED. Now, I've attached an LED to my Arduino just to show, make it easier for you to see. But you should note that the LED on the Arduino, there's an onboard LED, and that is connected internally to pin 13. So that's the pin I'm going to use for this tutorial. So the first thing we would like to do is we would like to say that our pin 13 is going to be an output. It's going to turn something on or off. So pin mode, pin 13 is going to be output. And we end each line with a semicolon. And for right now, let's just turn it on. So what this sketch is going to do, there's going to be nothing in the loop, and we're going to call digital write 13, and we're going to turn it on, and on is high. So then let's upload this to our board. First thing we want to do, we want to click on Tools right here. We want to make sure that the correct Arduino board is selected. In my case, I have an Arduino Uno, so that's correct. And then we want to make sure our serial port is correct. And I know that my Arduino is connected to COM5, so this is all good. And then we can go ahead. This will verify code to see if you have any errors in the actual code. So I'm just going to save this as blank. It's compiling my sketch. It's done compiling. There's no error in my code, and I can upload my sketch. And you'll notice when I upload my sketch, this LED turned on, and there's nothing in my void loop that will change anything, so it will just stay on. Now, I said I want to blink an LED, and what I'm going to do is show you a way to blink the LED that is easy to read, and then I'm going to show you a way to blink an LED that is will deal with some programming aspects that you may or may not be familiar with. but it isn't exactly how I would blink the LED. It's just to illustrate some different programming things to you. So we can get rid of this digital right here because I want to put that in my loop. So what I want to do is I want to have my LED blink for 1 second on and 1 second off. So the first thing I have to do is, again, turn my LED on. So I want to use digital right, my LED, which is pin 13, and I want to turn it on. And since I want to turn it on for 1 second, I want to pause for 1 second. So I'm going to use this delay of 1000. Delay, I'll write it up here. Delay is a delay in milliseconds. So 1000 milliseconds is equal to 1 second. So I delay for 1000 milliseconds, which is 1 second, and then I want to turn my LED off. So digital right, 13 low. So it's going to give 0 volts. And again, I want to delay for 1000 milliseconds. Now, if I don't have this delay right here, I'll show you what happens in a second. But first, let's upload this sketch. You can verify your code, but when you upload it, you'll see this Arduino. It blinks for 1 second and turns off for 1 second. If I had forgot to put this delay at the bottom, the Arduino will just stay high forever. Because when I upload this, it immediately goes from a low state to a high state without any delay. So what's happening is there's no delay, and it blinks so quickly our eyes can't see it. So this is how you blink an LED. Okay, so the last thing I would like to do in this video is to show you a different way to blink an LED using different type of programming logic that maybe I'll introduce you to thinking about it in a different way. Now, I am going to say if I had to blink an LED, I would blink it this way. It's very readable, you know exactly what is happening. But I do want to introduce programming concepts to you. So the first thing I want to do is I want to comment out the code that I had just written. And now there's two ways to comment out code. I can use these double slashes. So if I do / and I can write this as a comment, I can write a comment this way. Or if I want to take out a block of code, I can use a /* and a / where the code that I want to comment out ends. The other thing is, look at this. We have this pin number 13 in a lot of different places. Now, we know this is our LED pin. It's not confusing to us in this tutorial because that's the only thing we're dealing with. But if you work on a project and you're interfacing to 4 or 5 more sensors, it's going to get confusing to use the actual pin name to remember this. So what we want to do is we want to make that a variable. So I want to declare my variable as an integer. So int LED pin is equal to 13. So right here, I'm saying that this variable type is an integer. And an integer is a number in C that is between negative 32,767 to 32,767. So it can be any number in between. For us, we're picking 13. And then whenever we see this number 13, we can replace it with LED pin. So right now I just have this pin mode as LED pin. Now, Okay, so I want to think of my LED of having two states. The state of my LED can either be on or off. So if the state of my LED is on, then the next state is off. If the state of my LED is off, then the next state is on. And what I'm going to have to do is I'm going to have to declare a variable that I hold as state. And I'm actually going to declare it as a Boolean. So my Boolean state is going to be equal to, let's start it off. So let's start it as low. Now in programming, a Boolean can either be true or false. And with Arduino and different ways of thinking about that, false is going to be equal to 0, and false is also going to be equal to low. True is going to be equal to 1, and this is also going to be equal to high. So all these terms are synonymous with each other, and I can use any of them with the Arduino language. So what is this saying? This is saying if the state of my LED is on, then the next state is off. If the state of my LED is off, then the next state is on. So what I'm going to do is write an if statement, because this is what it really needs. So if the state of my LED is on, so if state. Now this is going to evaluate this variable right here. If this is true, which it won't be at first, but if this is true, then then whatever code is in this braces will execute. So code to execute if true. If it's not true, we need an else statement. So my else statement is going to be what happens if my LED is off, because it's not going to be it's not going to be this if statement. So else, right here, this is going to be code to execute if false. So if my state is true, then my next state is going to be off, and off is going to be low. If my state is low, then my next state is going to be on. So every time through this loop, this if statement will change what my state is. And then what I want to do is I want to digital write LED pin, and I want to write it at whatever my next state is, and delay, say 2000, so 2 seconds. So you'll actually be able to see this LED change. If I verify my code, it's done compiling, so I have no errors, and I can upload to my Arduino. It's blinking quickly, so it's uploading, and there it is. It is blinking very slowly. 2 seconds on, 2 seconds off. Now I can make it go faster, so I can just change my delay, upload it to the Arduino, and it blinks much faster. So this is just a different way, hopefully, to expose you to some programming logic of how to blink an LED. But again, if I actually had to blink an LED, this is the first way I showed you is a much simpler way of blinking an LED. So I hope you enjoyed this tutorial on how to blink the LED, and I hope to put another video together shortly.